If I asked the average person what a galaxy was, they'd probably say it's a large collection of stars. This isn't exactly incorrect, but it's a little bit vague, especially because, for example, a globular cluster is a large collection of stars, but it's definitely not a galaxy. So what exactly makes a galaxy a galaxy? The most common definition of a galaxy is that it's a system of dust, gas, dark matter, and anywhere from 1 million to 1 trillion stars that are held together by gravity. This definition excludes some of the smaller dwarf galaxies, but they have their own category anyway. There are many kinds of galaxies, including dwarf galaxies that I mentioned, but also a few others. So we have spiral galaxies, irregular galaxies, elliptical galaxies, lenticular galaxies, diffuse and ultra-diffuse galaxies, active galaxies, Seyfert's galaxies, peculiar galaxies, then subsets of each of these galaxies, and more. However, looking at it in its most broad view, there are spiral galaxies, elliptical galaxies, and lenticular galaxies. I'm also going to talk about irregular galaxies just because they're really interesting. The spiral, elliptical, and lenticular galaxies are according to the Hubble sequence, which is a classification scheme for galaxies invented by Edwin Hubble. Spiral galaxies are definitely the most recognizable. Surprisingly, you can recognize them by their spirals. Most spiral galaxies have a flat rotating disk that contains stars, gas, and dust, and they have a bulge where there's a higher density of stars than in the rest of the galaxy, meaning that the bulge is also brighter than the rest of the galaxy. These are often surrounded by a much fainter halo of stars, which are mostly in globular clusters, and we have these globular clusters in our own galaxy too, around 150 of them, but probably more. And as almost all galaxies have, this surrounded by a spherical dark matter halo. I say almost all because there's always the occasional paper saying that there's a galaxy that they found without dark matter, but it's pretty much assumed that most galaxies, if not all galaxies, have a spherical dark matter halo, especially the more massive galaxies. Our home galaxy, the Milky Way, is an example of a spiral galaxy, as is Andromeda, which is a barred spiral galaxy, meaning it just has a bar through the middle and then spirals on the opposite ends and sides. Some astronomers have performed a census of different galaxy types, and they've looked at galaxies from many billions of years ago, even before the Sun existed. And they found that more than half of present-day spiral galaxies had peculiar shapes over 6 billion years ago. And a peculiar galaxy is pretty much as it sounds. It's a galaxy that is very unusual. It's unusual in terms of its size, shape, and or composition. And this suggests that peculiar galaxies become more normal as time goes on. There are many different types of spiral galaxies, including barred spirals, like I mentioned for Andromeda. You also have some with trailing or leading arms, and some with a more prominent bulge than other galaxies. And another feature of galaxies, more massive galaxies in particular, is that they have a supermassive black hole at their center. Now let's talk about elliptical galaxies. An elliptical galaxy is a galaxy with a roughly ellipsoidal shape and a smooth and featureless image. Most elliptical galaxies are composed of old low-mass stars with barely any interstellar medium and little to no star formation. They also tend to be surrounded by large numbers of globular clusters, which, given their age, kind of makes sense. If you have loads of old red stars in elliptical galaxies, globular clusters are also composed of those types of stars, so I think it's fair enough to assume that that would have been the case in the first place, but luckily, our assumptions match the observations. Galaxy clusters are large groups of galaxies bound together, and for some reason, elliptical galaxies are found close to the center of galaxy clusters. Elliptical galaxies can also have anywhere from 10 million stars to hundreds of billions of stars, which is a huge variation in size, which is very difficult to appreciate and comprehend. Originally, Edwin Hubble hypothesized that elliptical galaxies evolved into spiral galaxies. However, this later turned out to be incorrect. Now, let's talk about irregular galaxies. You won't be surprised to find out that irregular galaxies are irregular. They don't have a distinct shape, unlike a spiral or an elliptical galaxy, and they can pretty much look like anything with neither a clear bulge or any spiral arm structure. They're estimated to make up about 25% of all galaxies. It's suggested that some irregular galaxies could have been spiral or elliptical galaxies, but were heavily deformed by an external gravitational force. Irregular galaxies are quite small, about 10% the mass of the Milky Way. And due to their small sizes, they're often involved in collisions with large galaxies and intergalactic clouds. This leads them very vulnerable to being changed and smashed around and just having all sorts of stuff done to them. And lastly, we have lenticular galaxies. Lenticular galaxies are disk galaxies, and they're like a hybrid between spiral and elliptical galaxies. They have the central bulge and disk like spiral galaxies, but no arms. And like elliptical galaxies, lenticular galaxies have older stellar populations and little to no star formation. One idea of how these galaxies are formed is that these were spiral galaxies whose arms have now faded due to age. And another idea proposes that lenticulars formed from mergers of spiral galaxies. But there's nothing conclusive on that front. So that's it. If you want to read more about galaxy evolution and galaxies in general, different types of galaxies, I have references to what I talked about in the description below. I also have my TikTok, Twitter, and website link in the description, so click those if you want. And I guess I'll see you next week for another episode of me talking about astrophysics.